Okay, so today we wanted to talk about the matrix operations and their applications. Yeah. Okay, so first thing we will have the matrix notation and understand what is meant by equal matrices and subtract matrices, and you have special restrictions here. Okay, so it's not like every two matrix you can subtract and perform scalar multiplication and then solve matrix equations. Multiply matrix you also have restrictions too. Okay, and then you modeled applied situations with matrix operations. Okay, so what will be a matrix? So an array of numbers arranged in rows and columns and placed in brackets. Yeah, so it's called a matrix. We have already defined like for you have 1, 2, 3, 4, 5, 6. Yeah, so in rows and the lowercase letter included in the bracket such as aij can denote a matrix. And what is aij mean? This means the element in the ith row and jth column. Okay, so this is the element in the ith row and jth column. Okay, oh my god, so okay, so it's right here, so I do not need to write it, do it, yeah, here. Okay, so a matrix of order m multiplied by n. Okay, so it will be for the matrix which has m rows and n columns. So if m equal to n, a matrix has the same number of rows as columns, and it is called what? Square matrix. Okay, so this. Okay, example matrix notation. So A equal to what? 5, -2, -3, pi, 1, 6. Yeah. So what is the order of A? Rows by columns. Yeah. How many rows? 3 rows. How many columns? 2 columns. So the order is what? 3 by 2. So what will be A12? Oh, not A, yeah, A12. Yeah. So what will be A12? The first one is this one is your row. This one is your what? Column. Yeah. So it's first row, second column. It's right here. So it's -2. This will be what? The third row, the third row, the first column. It's right here. Yeah. Are you guys okay? So it's very easy definitions. Okay, definition of equality of matrices. So what will be the equal matrix? Two matrices A and B are equal if and only if they have the same order, and Aij equal to Bij for all elements. Yeah. So it has to be what? Exactly the same. Then two matrices are equal. Okay, so it's exactly the same. No matter whether the form or the values has to be exact the same. Okay. And how could you add or subtract matrix? Okay, so when could you do that, add or subtract? When you have what? Have the same order m cross n. Yeah. And when you add or subtract, what will you do? You just add and subtract the corresponding, the values in the same location in the matrix. Yeah. So Aij plus Bij. So the ith row, this column and the ith row of this column of both matrix, and then you add or subtract together. Yeah. So this is the example. And similarly, you do this for the subtraction too. Okay, and then so this is another example. Well, I don't know why they do one more. Okay, so but it's good to practice. Yeah, negative 4 plus 6, 3 plus negative 3, 7 plus 2, negative 6 plus negative 4. Yeah, good. Yeah, so here the first step. So what is the order of this matrix? 3 by 2, 3 by 2, and then it's the same order. You can do the subtraction. Yeah, and then subtract each one, but be careful when you subtract. Be careful about signs. 5 minus what? Negative 4 means plus 4 is 9. A lot of students will be like okay, so make a mistake when they forget about the lines. Okay, so this one. Okay, so if A, B, and C are M cross N matrices and 0 is a M cross N 0 matrix, then the following properties are true. A plus B equal to B plus A. A plus B plus C equal to A plus B plus C. A plus 0, 0 plus A equal to A. A plus negative A and negative A plus A equal to what? 0. Okay, so this will be this one. Okay, so all these properties are pretty straightforward. And if you have multiplication, what will you do? This means a scalar has to multiply what? Every element in the matrix. Okay, so it has to multiply every element in the matrix. Okay, so if A equal to this, B equal to this, okay, so negative 6b will be what? Negative 6 times every element in the matrix. Every element in the matrix. Okay, so it's like this. Okay, so and similarly you can do 3a plus 2b, do all these things is 3 distributed to every one of them, and then 2 distribute, and then you add each one of them, carefully. Okay, and then we have properties of scalar multiplication. CD multiply with A, you can do CD, and here you have 1 multiply with the matrix, it's the same thing. You also have distributive properties. C times matrix A plus matrix B, and when could you add to matrix? Yeah, so because they are having the same order, so then you can do the addition with the matrix. Yeah, so then you can also do the two numbers. Yeah, okay, so 3x plus A equal to B, where A equal to this, B equal to this. Yeah, so you can do this, solve this too. Yeah, so you is 3x equal to b minus a, and x equal to 1/3 b minus a. Yeah, so this is this is what how you solve it, and then you b subtract a because these both are 2 by 2. You can do this, and then you use what? 1/3, distribute 1/3 to each element. Yeah, so that will be this one. Okay. So the next one is a matrix multiplication. Okay, so definition of matrix multiplication for 2 by 2. Okay, so what will you do for the matrix multiplication? Means the first row times the first column. So the first row times first row times first column. What will you do? A times what? E plus what? B times J. Yeah, so this this row column. Okay, and then row with second one, what do you have? A F plus what? B H. You with me? Okay, so what do we have for the bottom one? So you have C E plus what? D J, and then you have what? C F plus what? D H. Yeah, so this is how you do this. Yeah, so what did you also notice? So for here, because the rows has to times the columns here, yeah? So what happens? The number of columns of A has to be equal to what? The number of rows of B. Okay, otherwise, you do not have exactly the same amount of numbers, and then you cannot do the multiplication. Okay, so later on we will be able to find it. Okay, so A times B, yeah, so you do follow these rules. 1 times 4 plus 3 times 1 is 1 times 6 plus 3 times 0. Add all these things, you will get this. Okay, so for the definition of the matrix multiplication, so from what we just noticed, yeah. So the product of M plus M cross N matrix and N cross P matrix B is the MP matrix AB. Okay, so when could you say, what did you notice? Here is N, here is N. In order to make this multiplication happen here, so the number of columns here has to be the number of rows here. Are you with me? So this is very important. Okay, so this is what I just said. For the number of two matrices to be defined, the number of columns of the first matrix must equal the number of the rows for the second matrix. This is what I just mentioned here. Okay, so here is 2 by 2. What is here is 2 by 4. So these two are the same, yeah. Then what could you do? Oh, go ahead. You can do the multiplication. You can do the multiplication here. So this one is this, and here is 2 by 4, and here is 2 by 2. What happened here? Not equal. 4 is not equal to, yeah. What happens? No multiplication. No multiplication. Yeah, so A, B, C are matrix. C is a scalar. So A, B, C and A, like associative property. A times B plus C, AB plus AC, distributive and associative. Do we have AB equal to BA? It's commutative. Do we have this property? No. You can look at the example here, yeah? The above example. So you can do the A times B here, but could you do B times A? No. It's not even defined, yeah? So you do not have this thing. Okay, so application. So consider the triangle represented by the matrix like this. Okay, so what do we want it to do? To move the triangle 3 units to the left and 1 unit down. To the left means minus 3. To the down is minus 1. Yeah. So what does this mean? We wanted to to minus 3, minus 1, minus 3, minus 1 for all 3 coordinates. Yeah. So this is what we do. You minus 3, minus 1, minus 3, minus 1. Yeah. So because the top one is x coordinate, and so to the left means x. To the down means y. So this is minus 3, minus 1, or 3 of them. Good. Okay, so we consider the matrix, the same matrix. We wanted multiply the matrix by, to enlarge the triangle to twice its original perimeter. Twice of the original perimeter means each side to be doubled. Yeah, so what does this mean? Each side to be doubled. Yeah, each side to be doubled here. So what happens here? What should we do here? Is multiply by 2, yeah? Yeah, so you multiply by 2. When you multiply by 2, what happens? You multiply every element here by 2, yeah? So 0, 0 does not change because 0 times anything is 0. 2 times 3 is 6, 2 times 5 is 10, 2 times 4 is 8, 2 times 2 is 4. Good. Okay. Okay, so then the last one. So we wanted to find b times a, yeah? So what happens here? When you b times a, and when you see, excuse me, so when you do the b times a, what did you notice? Oh, it's a shift of the matrix, yeah? So what will be multiplication of this matrix B? It reflects the original triangle over the x-axis, okay? So this is a special matrix. If you multiply this matrix, and it's a reflection over the x-axis. Okay, so this is, for you to know, okay? Okay, so that will be this section.